My name is Vasilis Pais, and I'm an electrical engineer and project manager working for Grenzebach Hellas, that when this project started was called INOS Hellas. INOS Hellas, and now Grenzebach Hellas, is a small company with approximately 30 employees located in the Athens, Greece metropolitan area. We were originally a fully owned subsidiary of INOS Automation Software located in Stuttgart, Germany, but we are now a fully owned subsidiary of the Grenzebach company, which is a member of the Grenzebach group of companies located in Hamlar in Bavaria, Germany. We still support INOS Automation Software as a technology development arm, but we also support the complete Grenzebach group. The group is a sole proprietor family business with nearly 2,000 employees worldwide, and INOS specializes in the automotive sector, where we provide machine vision solutions for industrial inspections, and we also provide robot guidance for assembly operations in the automotive sector again. The Grenzebach group is highly diversified. As a group and an engineering-driven company, we make production lines for glass, flat building materials such as gypsum panels and wood veneer panels. We have a company that makes automated guided vehicles and vehicle management software for intralogistic applications. We have a unit that creates friction stir welding machines. We have a unit that specializes in creating handling systems for making additive manufacturing into a serial production operation. We have a metal processing and a large casting facility in Zhejiang, China. We have a division that specializes in digital solutions for the industry, implementing Industry 4.0 solutions and Internet of Things solutions. And we have a vertically integrated company that uses technology available in the group to actually manufacture not a production line but a finished product, and that product is vertical facades that generate photovoltaic power while providing a front for a building. The company focuses on customer service and environmental responsibility. Both as a group and as the INOS company, we work closely with our customers, creating bespoke solutions, adapting as necessary our standard offerings to specific customer requirements. We strive to make products that are ecologically and socially responsible by optimizing for energy and resource usage. In AI Proficient, we are the vision system specialist, developing technologies for industrial machine vision and AI running at the edge, including AI running in computers located right inside the production cells. We export the information derived there via database and Internet of Things interfaces. As part of AI Proficient, our aim was to use the project to train our engineers on AI and machine learning beyond what we already knew, to develop new Internet of Things functionality and integrate it in our systems, to introduce deep learning support to our systems, to implement intelligent clustering solutions in our systems, and we have targeted monitoring of machine condition via visual inspection of process flow, which we are implementing as part of the continental use case 7. Our secondary targets were bin picking and industrial inspection applications via deep neural networks. We have also tried to implement causality detection via neural model analysis of large historical datasets, but our results were inconclusive. Concerning the benefits that AI technology can offer to the manufacturing industry, we consider AI technology to be a game changer in this industry, as it's potentially a game changer in many other domains. As with all tools and technologies used in manufacturing, the main benefit is productivity enhancement. Processes that were formerly labor-intensive become capital-intensive, and the employee productivity is driven by how many processes can become relatively human intervention-free. Predictive and proactive maintenance, driven by non-linear AI trade models, is a case in point, where unplanned maintenance is minimized, both maximizing scheduled plant availability and reducing the level of staffing required to be on standby. The second category of benefits is quality enhancements driven by variability reduction based not just on statistics, but on implicit process modeling, which is again implemented using AI techniques. AI modeling can and is being used to identify information hidden in large amounts of process data and to create actionable reports that allow process engineers to adjust and fine-tune processes, and in particular processes where longer time constants require predictive capabilities. While this is not new, deep neural networks coupled with high-performance yet cost-effective sensors allow inspection processes that formerly had to be performed on a sampling basis to be now performed on a census basis. For example, in industrial inspection, it is now in many cases possible to inspect 100%. The third benefit category is improving the nature of industrial work by removing repetitive mechanical work in applications where this was not possible before due to positional or material variability. A case in point is parts bin picking and alignment. Our focus is on using artificial intelligence for vision applications, taking into account the specific low false positive requirements of serial station manufacturing, as for example is exemplified in the automotive industry. In serial manufacturing, a complex product, such as a car, goes through a line of stations with a number of processes per station. The overall line is broken into SOPs, for example press SOP, body SOP, paint SOP, and assembly when making cars. There are tens and possibly hundreds of stations and hundreds to possibly thousands of processes in total, each process having one or more steps. Measurement processes in particular have multiple, common tens of measurements as their constituent steps. When a problem is detected, including false positive detections, the product is sent to a bypass line where it is manually repaired, or it is manually again determined to have been a false positive. Using AI models trained even to, let's say, 98% accuracy with respect to false positive errors, which is an adequate rate for many applications, will in an automotive setting send more cars to manual repair than the process can handle. This will needlessly slow down production. In a different setting, where the production volume is much higher, a large rate of false positives will increase the numbers of rejects or the amount of manual work needed further down the line. To avoid this, we need to combine deep neural networks with search-based approaches in a hybrid scene where they complement each other. We use AI for clustering rather than directly for classification, and provide that as an input to more traditional classifiers. We focus on measuring the process rather than the product, under the assumption that process trends can be used to proactively maintain equipment and adjust processes, thus keeping defects from occurring in the first place. This is what we are trying to do in the continental packing and cutting station demonstration use cases, where we are attempting to use hybrid AI and pattern matching methods to detect deteriorating thread cuts, therefore identifying cutting blade deterioration. And we are also detecting tire thread positioning threads in the packing station to detect deteriorating feed belt conditions. Thank you for listening to my interview, and I hope that you have found it interesting.